In this video we have one indefinite integral to evaluate. It's one of 10 randomly selected problems of the different types you can have in integration. So one of several techniques. This will be the first one of the 10 that I've selected randomly. And if you want to pause the video and try this, go ahead. And then I'll come back. Okay, so when you first look at this, you look at the integral, it's a rational expression. So you would think partial fractions would be one way to go. The next thing, of course, is the degree of the numerator is not less than the degree of the denominator. So we have to go ahead and divide to simplify this. So I've set it up here. Numerator is x squared divided by divisor, x squared plus 2x minus 15. So x squared into x squared, long division here, is 1. And then 1 times x squared, 1 times 2x is 2x. Then 1 times minus 15 is minus 15. And then we subtract. X squared minus x squared cancels. 0 subtract a 2x is a minus 2x. And then 0 subtracted negative 15 is a plus 15. Now the degree of the divisor is 2. And the degree of the remainder is 1, so we can't continue the division. So the answer is going to be 1 plus the remainder, which is minus 2x plus 15, over the divisor is x squared plus 2x minus 15. So this then would replace the integral we started off with, and then we take it from there. So let me just go ahead and clear this for now. So always put an equal here then. So this is going to be 1 here plus minus 2x plus 15 over the x squared plus 2x minus 15. So we can break this up into two integrals here. 1 and the other integral would be negative 2x plus 15 over x squared plus 2x minus 15. So this would equal 2 then. Antiderivative, or the integral of 1 with respect to x, this would just be an x right here. And we got the integral then of minus 2x plus 15 over x squared plus 2x minus 15. And now here we have the degree of the numerator less than the degree of the denominator. So we can proceed with partial fraction decomposition. So this will be minus 2x plus 15. We'll take this out to the side now. And the denominator here can be factored into x plus 5 and x minus 3. And since we have distinct linear factors, this then, using partial fraction decomposition, would break down into some constant a over the first factor x plus 3 or x plus 5 plus another constant b over the factor x minus 3. And if we had another distinct factor, then we have another fraction plus c over that factor. And then here we just go ahead and multiply through. So a couple of ways to do this, but we just do it this way: minus 2x plus 15, and we multiply through by the common denominator, x plus 5, x minus 3. So that'll clear the denominator on the left side. On the right side, this would give me an a times x minus 3. The x plus 5 would cancel, and then the b, the x minus 3 would cancel. When I multiply both sides by x plus 5 and x minus 3, this would give me x plus 5. And there are several ways to take it from here. You could go ahead and simplify the right side and collect all your linear terms, your constants and so forth, and set those equal to the corresponding parts on the left side, and you solve a system of equation. This actually turns out to be an identity. So you could also just pick a number for x and get an equation, pick a number for another number for x, get another equation, and solve it. But in this case, we could just do this and say, well, let's let x minus 3, we got x plus 5. So convenient to pick x equal to 3. So let's pick x equal to 3. What do we get here? x equal to 3. Here gives me 3 minus 3 is 0, so the 8 cancels. And then over here 3 and 5 is 8, so I get 8b. And then on the other side we get a 3 times negative 2 is negative 6. And 15 gives me 9. So this tells me, dividing by 8, that b is equal to 9/8. So now I know b. And then I want to find out what a is. So let's cancel the b by letting x equal to negative 5. So x equal to negative 5. Notice over here, negative 5 where the x is, wipes out the b. Negative 5. The negative 3 is a negative 8. So I got the coefficient of a then would be negative 8. And this would equal 2. On the other side, this would give me negative 5 there, be 10. And 15 is 25. So I get negative 8 is equal to, negative 8a is equal to 25. So a would equal to 25 over negative 8. Or just make it negative 25 over 8. There we have it. So that means then this expression then could be broken down using this information for the a and the b into two integrals. So a is negative 25 over 8, and that would be over the corresponding factor x plus 5. This would be dx then, and then the other integral then, using the other value for b, be 9/8 over x minus 3, and this will be dx. And now it's pretty much set up here. So this then is going to equal to x plus, so we have a constant in the numerator, we got x plus 5, and it's first degree, so that pretty much tells you that's going to be the natural log of absolute x plus 5. With the coefficient, this would be negative 25. Negative 25 over 8. And pretty much the same thing with the next one. Got x minus 3. You can let u equal to x minus 3. Find your du and dx would just be the same thing, but this is pretty straightforward. This will be ln x minus 3. And then you have the coefficient, 9 over 8. And then you have constant of integration. So this is one that involved partial fraction decomposition, but it's also one where we had to reduce or simplify the integrand by doing the long division and rewriting the integrand. So we have x minus 25/8, natural log of x plus 5, absolute x plus 5, plus 9/8, natural log of absolute x minus 3, plus the constant of integration. So this is the first of 10, and more coming up in the future, along with other videos on technology and miscellaneous things that I do also. Thanks for watching, and we'll see you next time.